All right, guys, Chapter P, Section 4. All right, Chapter P, Section 4, factoring completely. Okay, this is not any section where it's going to tell you factor using GCF, factor using grouping, factor using, it's going to say factor completely, which means we have to go through all of our steps and make sure we simplify as much as possible. So you might have to do a few things. The first thing you should always look for is the GCF. Always check for the greatest common factor. It makes your problem a lot easier and it'll make your numbers a lot smaller. If there's two terms, check to see if it's the difference of two squares or the sum of difference of cubes with our patterns. If there's four terms, we should group. And if there's three terms, check to see if it's a perfect square trinomial. And then if all else fails, then we just factor normally, right? All right, so let's go through. Every single time we have a problem and it says factor completely, we need to follow these steps. The first thing we look for is a GCF, greatest common factor. In number one, what is the greatest common factor between 12x squared and negative 48? 12. Okay, if I divide out of 12, again, we made this mistake on our test and some of you on your quizzes. When you factor out, you bring it out in front, but it does not go anywhere. You're just moving it to the front. So 12 divided by 12 is going to give me x squared. And then what's negative 48 divided by 12? Negative 4. Perfect. Now, if we stop there, have we factored completely? No. Because I'm now left with two terms. I took out the GCF. But is this the difference of perfect squares? Yes, x squared is a perfect square, 4 is a perfect square, there's a minus sign in the middle. So when we factor completely, this becomes 12 times x minus 2 and x plus 2. Does it matter where you put the plus and the minus? No, since they're both 2.
How come you did 2 equations?
What do you mean 2?
Like from that, you made it x minus 2 and x plus 2?
Because this is the difference of perfect squares. What times what gives you x squared? It's x and x. And what times what gives you negative 4? It's going to be 2 and 2. And then the pattern when you have difference of perfect squares is two binomials, same factors in each, but one plus sign, one minus sign. Okay. All right, let's look at number 2. First thing I'm going to do is take out an x. They both have an x, so we're going to divide out an x. It does not go anywhere, we're just bringing it out in front. So when we divide out our x, we're left with x squared what? Minus 16. Now we say, okay, I'm left with two terms. Is this something special? Is this the difference of perfect squares? Yeah. Yes. So what can I break this down into? Tell me, go ahead. Say it one more time. X minus 4, x plus 4. Perfect. Good. Good. We always, guys, simplify as much as possible. Number 3, what's the issue with number 3? We talked about something like this yesterday. What's wrong, Frank? Starts with a negative. We don't like that. So what should we do immediately? Factor out the negative. Is there, other than negative 1, is there anything else that we can take out of all three terms? No. So let's just go ahead and factor that out. We're going to factor out, divide everything by negative 1. My negative 1 goes out in front. It does not just disappear. Once you guys take out the GCF, some of you did that on your quiz, you've got to take it out and keep it in front. So this becomes 9x squared. What's 6x divided by negative 1? Negative 6x, good. And then negative 1 divided by negative 1 is positive 1, all right? Now we're left with three terms. We took out our GCF. Excuse me, we're trying to factor completely. Did anybody notice anything special about this? 9x squared minus 6x plus 1. Is this a perfect trinomial of some sort? Is it, Ariana, you're saying yes? Okay. What times what is going to give me 3x squared? Sorry, just kidding. 9x squared. 3x and 3x. What times what's going to give me 1? 1 and 1. All right, so I'm going to write two binomials. This negative 1 is staying out in front. Do not do anything with it. Don't just drop it. Don't forget about it. Rewrite it out in front. What do my binomials look like? 3x in the front of each, yeah? 1 at the end. And what are these signs? All right, what happens if I put a plus and a minus? I like what you're thinking, but what happens when I put a plus and a minus? If I FOIL them back together, what's going to happen in the middle terms? it's going to cancel out. We want to have, whenever we have a perfect square trinomial, you're fine. Whenever you have a perfect square trinomial, you're going to have the same sign in each parenthesis, and it's going to be that middle sign.
Oh, can't you just put the to the second power?
I was, oh, you're 3 steps ahead of me. What's another way I can write this, Hannah? -1. Uh-huh. 3x minus 1 to the second power. Perfect. Good. Quantity squared. Now, guys, remember, on all of these problems, at the end, if you're kind of like, oh, man, I don't know if I have my signs right or whatever, what can you do? You can remember? You can foil it. Foil it and make sure that what you ended up with is what you began with. Scooting along, right? The numbers get a little bigger. No big deal. What is the first issue I see with number 4? There is a greatest common factor. Agreed. Correct. I like to rewrite so we have everything in descending order. So when I rewrite this, guys, that negative stays with your cubes. Yeah? So negative 3x squared plus 9, cubes, plus 9x squared plus 12. Perfect. Now I do see the GCF. What is it? What kind of 3? Negative. Why are we going to take out a negative? Because it's in the front. When we lead with a negative, we'd like to just get it out of there. It's much easier for us to do. So if I take out the negative 3x, remember, it's not going anywhere. We're just moving it. We're relocating it. So negative 3x, and I'm left with x squared. 9 divided by negative 3 is? Perfect. And then 12 divided by negative 3 is? -4. Okay. Have I factored this completely? Yes. Let's think about it for a second. Is this a perfect square trinomial? Hold on. Wait. Is it a perfect square trinomial? Talk to me, Ariana.
Yes.
Yeah, so it's not. But can we factor this using our traditional factoring methods? Yeah, of course. So I have negative 3x out in front. Guys, what are the factors if you multiply a times c, 1 times -4? What are the factors of -4 that multiply to give you -4, but add to give you a -3? Perfect. X minus 4, x plus 1. Would it be okay if I wrote x plus 1, then the x minus 4? Yeah. Just got to make sure your signs are correct. Again, take a second before you run on to the next one and just check. Say, okay, -4 times 1, does that give me -4? Yes. -4 plus 1, does that give me -3? So that's good. All right, then we get to these wacky ones. We're like, oh no. How many terms do you guys see? 2, 3, and 4. Which ones? I see this term here and this term here. You have 2 terms. That's okay. That's fine. Is there a greatest common factor between these two that we can take out? No. Is this something special? Is this maybe the difference of perfect squares? How many x squareds plus 8s do you have? 2. So could I break this up? Okay. X squared plus 8 and x squared plus 8. Okay. What about 36x squared? 6x and 6x? Okay, perfect. Perfect. So my first parenthesis is going to be...
Would it be -6x?
Well, 1 will be. We're going to have x squared plus 8 plus 6x. And we're going to have x squared plus 8 what? Minus 6x. Do you guys want to rewrite that? No? You just want to leave it? I'd rather you not. Can I combine anything in either of those parentheses? Can I combine x squared with 6x or 8? No. Okay. All right. Sorry, I wasn't even thinking about that. I know. Guys, can we factor this anymore? Yes, we can. Are there factors? If we have a trinomial, yes? Are there factors of 8 that'll multiply to give me 8, but add to give me 6?
2 and 4.
Think about this. We want the whole number 8. What's going to multiply to give me 8, but add to give me 6? Hannah, what'd you say?
2 and 4.
X plus 2, x plus 4. Good. Ay, ay, ay. What about over here? Can I factor this more? Factors of 8 that multiply to give me a positive 8, but add to give me a negative 6? Negative 4 and negative 2. Very good. So x minus 2 and x minus 4. Yeah.
For the first equation out there, it's two positive signs. You can still factor because it becomes a full equation, not just
Yeah, you can still factor it because it's not, we're not doing like the difference of perfect squares or anything. Yeah. Anything else there? That's complete. Worried about getting web assigned done. I've been doing it a long time, kiddo. All right, look at number 6. GCF. No? Okay. Is there something different about this one? There's 4 terms. What do we do with 4 terms? We group. So we're going to first 2, second 2. What do I do with that middle sign? That third sign stays with our number, correct? All right, so 3x cubed and x squared. What can we take out? X squared. So I'm left with 3x plus what? Good. Negative 27x minus 9. Negative 9. And I'm left with
plus 1.
3x plus 1. How do we know we're on the right track just by looking at this so far? Because those 2 parentheses are the same. So we're going to take it out, write it out front one time, 3x plus 1. And then my leftovers get what? Their own parenthesis, right? Can I factor any more? Yeah. X squared minus 9 is what? Difference of squares. So I have 3x plus 1, x minus 3, and x plus 3. Good. Good, good, good. How we doing? All right, let's look at the last one. How many terms do you guys see? I got a term here. I got a term here. I have 2 terms. Is this the difference of perfect squares? No. What's the sign in the middle between those 2 terms? It's a plus, so it's not a difference. Okay, good. Do they have anything in common? They have a 2x minus 1. They each do. 2x minus 1 and 2x minus 1. Yeah? So this is going to come out in front. 2x minus 1. This leaves me with 4x plus what? Yeah, plus 2x minus 1. Can I combine anything? Correct. 4x and the 2x. This is going to be 2x minus 1 and 6x minus 1.
Where did you get the 2x from in the second parentheses?
Okay, so this term, do you agree with me, Hannah, would be 2x minus 1, 2x minus 1, because there's 2 of them? So we just divided out one of them. So that one was still left there. Good question. Anybody have any questions? All right, so what we're going to do now, we're going to go, everybody go to WebAssign. Go to the module on Canvas that says WebAssign, and everybody launch WebAssign. If you've done WebAssign before, you should be there. It'll just pull you into my class. If you haven't, we're going to create an account. And then once we create the account, we're going to talk about how to do our work. So go ahead and do that.